So today we're going to learn about how to determine if the triangle is acute or if it's right or if it's obtuse, right? But the first thing we have to do is we have to play a game. And the game is going to be, is it a triangle? So you're going to tell me, yes, it's a triangle. Here are my three options. It's a triangle. Or maybe it's not a triangle. Maybe it's a line. Or finally, maybe it's an open. Something like that where I can't connect them. Right? So here we go. Those are my three options. Is it a triangle? Is it a line? Kaylee Miller threw something into the Google Classroom. Or is it an open? Triangle, line, open. So here we go. Let's go 5, 3, 8. So if I have a triangle with side lengths 5, 3, and 8, is it going to be a triangle or is it going to be a line? So when I look at this, I see, okay, 5, 3, and 8. So normally you just draw this, right? But it might not look like that. And what I do is I pick two of the segments and I add them together and I subtract them. So I pick two of the segments, I add them together and I get 8. I subtract them and I get 2. So the third segment needs to be between 8 and 2. If it equals 2, it's not a triangle, it's a line. If it's bigger than 8 or equal to 8, then it's not a triangle either, right? It's a line. If it equals 8, it's a line. If it's bigger than 8, it's an open. So this thing right here, this is actually a line because I took these two, added them together, and they equal the third side. So this is going to be a line. Let's undo some stuff here. Let's give you another one. 7, 12, 15. Right? So which one is it? Is it a triangle? Is it a line? Or is it an open? So the way I would do this, again, I would pick two of the sides, and I would add them together, and I would subtract them. It's called the triangle inequality. You add the two sides together, and you subtract the two sides. When you add the two sides, that'll be the maximum the third side can be in order to be a triangle. And when you subtract the two, that'll be the minimum. So now, is 15 in between 5 and 19? Yes, it is. So this is a triangle. Easy. Easy. Let's do one more. And you're like, I know it's going to be open. Well, maybe not. Maybe not. Maybe it won't be open. Maybe it won't be open, Zaid. Let's go 5, 5, and 7. 5, 5, 7. You're like, I don't know. I don't know what it is. So you can pick any two sides. You can pick any two sides you want. I'm going to pick the 5 and the 7 this time. I'm going to add them together, right? And I'm subtract them. So when I add them together, 5 plus 7 is 12. 5 minus 7 is 2, or it would be 7 minus 5. Is my third side between 2 and 12? Yes, it is. So this is a triangle. Okay? The reason why I'm teaching this to you is because in order to figure out if it's an acute triangle, a right triangle, or an obtuse triangle, you have to first determine if it's a triangle. If it's not even a triangle, you don't have to worry about it, right? So, example 1. Let me take a second here for this to change over. Actually, I have to teach you a little something first. So, assuming it is a triangle, you're trying to figure out if it's right, acute, or obtuse. Assuming it is a triangle, here are 3 cases. Case 1, case 2, case 3. If a squared plus b squared equals c squared, it is a right triangle. So if that works out, then it's a right triangle. If the hypotenuse is bigger than the sum of the two sides squared, then it's an obtuse triangle. And if a squared plus b squared, or the hypotenuse, is smaller than the sum of the two sides, then it's an acute triangle. Right? So here it would be a squared plus b squared equals c squared. If that happens, it's a right triangle. If it doesn't happen, you have 2 other cases, assuming it's a triangle. So if you get a squared plus b squared is less than c squared. So the hypotenuse is bigger. The hypotenuse is bigger. So if you think about it, if I make my hypotenuse, it does look like this normally. If I make my hypotenuse bigger, now all of a sudden it's going to be an obtuse triangle. So if a squared plus b squared is less than c squared, then it's going to be obtuse. And then finally, if a squared plus b squared is greater than c squared. So now the hypotenuse is smaller. So normally they equal, but now the hypotenuse is smaller. So that's going to make it an acute triangle. That's going to make it an acute triangle. Let's do an example here. It might take a second for this to flip over. Let's say I have a triangle with side lengths of 3, 6, and 7. 3, 6, and 7. So first of all, you have to figure out which one you're going to make the c squared. For me, I'm going to make the 7 the c. I'm going to make 7 the potential hypotenuse. And the reason why is because the biggest side will always be the hypotenuse. So let's try it. Let's go 3 squared plus 6 squared equals 7 squared. So it should be equal if it's a right triangle. If it's not equal, then it's not a right triangle anymore. So we got 9 plus 36 equals 49. So we have 45 equals 49. So 49 does not equal 45. So now you have to figure out, okay, is it going to be obtuse or acute? So the way I think about it, this is your hypotenuse. These are your legs. The hypotenuse is bigger than your legs, right? So the hypotenuse is being stretched out. It's bigger than your legs. This is going to be an obtuse triangle. Boom. Let's do a couple more. Make sure you got it. Let's go 5, 12, and 21. 5, 12, and 21. So I didn't do this with the last one, but before you do anything, the first thing you should do is you should make sure it's a triangle, right? So let's check it. Take 2 of the sides, add them together, and subtract them to see if it's even a triangle. So 5, 12. 5 plus 12 is going to be 17. 5 minus 12 is going to be 7. Is your third side between 17 and 7? Nope. So this is not even a triangle. And if it's not a triangle, it can't be obtuse, acute, or right. Beautiful. Should have done that with the first one. Oh well. Let's use red. This is a nice color. Well, let's go 3. We'll go 3, 8, and 10. 3, 8, and 10. See how this one works. So again, let's check to see if it's a triangle. Take 2 of the sides, add them together, you get 11. Take 2 of the sides, subtract them, you get 8. 7, 6, 5. 10 is between 11 and 5, so now we're going, right? We know to make 10 our potential hypotenuse because it's the biggest side. So we're going to do 3 squared plus 8 squared equals 10 squared. If it's a right triangle, that should work out. If it's not, we got to talk. 3 squared is 9, plus 8 squared is 64, equals 10 squared, which is a hundo. So we got 73 is not equal to 100. So again, okay, 73 does not equal 100. So let's draw this. The hypotenuse is bigger. So the hypotenuse is bigger. Always think about it in terms of the hypotenuse and you'll never get it wrong. If you start to think about it in terms of the legs, then it gets a little confusing, but it makes perfect sense. Make the hypotenuse bigger, shoom, becomes an obtuse triangle. Make it smaller, shoom, becomes an acute triangle. So this is going to be obtuse. All right, let's do one last one here. Erase, erase. So let's say I have side lengths of 5 by 5 by 4. And we're going to figure out what type of triangle this one is. So the first thing we need to do is check and see if it's a triangle. Take sides, add them together. 10 is the biggest the third side can be. Take them, subtract them. 0 is the smallest that it can be. 4 is between 10 and 0, so we're in the money. We can go ahead and try that. Try the Pythagorean Theorem. So this one's kind of tricky because we don't know which one to make the hypotenuse, right? Doesn't matter. Pick one. Doesn't matter. So I'm going to go 4 squared plus 5 squared equals 5 squared. And you can already tell that's not going to be a right triangle, right? So we got 16 plus 25 equals 25. So right away, 16 plus 25 is going to be bigger than 25. So again, the hypotenuse is smaller. So let's go ahead and draw that. The hypotenuse is going to be smaller than the two sums added together. So therefore, this is going to be an acute triangle. ACUTE. AC. Is that right? I don't know. Alright, there you go. There's your quick little video learning about right triangles, acute triangles, and obtuse triangles. Peace.